Hello everyone, this is training an AutoML community call on 30th of October. This meeting will be recorded and published on YouTube. This meeting is governed by the Kubeflow Code of Conduct. Welcome everyone. Do you have any new people here on the call who just want to introduce themselves to the community? You want to say hello?
I'm new. I can introduce myself. Hi, I'm Vanessa. I'm a computer scientist at Lawrence Livermore National Laboratory. I hail from the high performance computing HPC community, and I am intimately interested in getting a lot of our workloads onto Kubernetes, and thus Kubeflow and the underlying job set is something that I think we should be involved in, and I want to chat about and help with. Nice to meet everyone.
Yeah, it's great. Thank you for joining us. Nice to see you. Anyone else? Right, so then maybe we can just get started. So maybe we can quickly talk about the release before we jump to the V2 progress. So Saraj, do you have any specific questions you want to talk about right now?
Yeah, so I just wanted to confirm, my present is good.
Mm-hmm.
Give me 1 second.
Yep.
Is my screen visible?
Yeah, we can see.
So this is our roadmap, right? So I just wanted to ask, so when are we planning on updating these in the MD file that we have in the repo?
Yeah, so this is the roadmap, but I think we also have an issue for 1.9, right?
Uh,
But maybe it's just a template issue. Let me see.
yeah, I think it's now taken.
Yeah, I think it's this one. So if you let me share it in Zoom chat, this one.
Yeah. 1 second.
So I think Ricardo previously asked us to create this issue so we can track it. I think roadmap has, so this is 1.9 and the roadmap is more kind of 2024, 2025 planning, right?
Right.
Right. Yeah, so I think, so the main goal for us for training operators is just V2 release and JAX. JAX already we support it in V1, right? But there are several bug fixes and also, supporting, I think, manage by, we introduce, maybe I can update it as well. Yeah, but we can track it in maybe this release issue, right? For 1.9.
Okay, so you want to track it in this one?
Yep.
Okay, got it.
Yeah, 1.9 will be, yeah, good.
Yeah, it would be great if we can add the issues, PRs as well to these, to the description. Like, just the PR numbers to know which one corresponds to which one.
You mean like tracking issues, right? For every feature?
Yeah.
Okay. Okay. Yeah, I can update the items what we have for 1.9. So 1.9 will be the latest release from our side for training operator V1. I think we have some plans to release it after the KubeCon around like December timeframe.
I see. Okay.
Yeah, because we want to release the V2 before the KubeCon. And I guess, yeah, the 1.9 will be in a separate branch forever. Like we're planning to support like for next 2 years before we migrate all the users, right?
Understood. So, have we decided whether we want Kubeflow 1.10 to have this only, like 1.9? 1.9 is for Kubeflow 1.10.
Yeah, I think the goal was to include 2 versions in 1.10. So we might need to have it 2 separate manifests for V1 and V2, right?
Got it. Okay. Makes sense. Yeah. Okay. And for Katib, can I just link this? This is fine, right?
Yeah, let me see. Yeah. So this is like, yeah, we have a lot of features actually for 0.18, which was contributed by GSOC students.
Okay.
Yeah, I think this is like the major one they have been contributed. So I can add the PRs as well there. Here, tracking issues if you want.
Yeah, it would be great since the PRs are already up. If we can update the roadmap and the as well for you.
Yep. Yeah, I think that makes
Yeah,
sense.
this one.
I guess you.
Hello?
Yeah, we can hear you. You probably need the Kubernetes version, right, from our side to be in sync.
Sorry, can you repeat that? I think I lost it.
Yeah, you might need like to have a Kubernetes version, right, from our side.
Correct,
Like,
yeah.
mhm.
As So these are the proposed Kubernetes and like dependency versions. I just
Yep.
want to know your thoughts.
Yeah. So I guess so. I know Ricardo also created this issue in the community repo, right, to track it.
Yeah, yeah.
So do you need any updates from us right now on this issue?
No, I just wanted to know if these dependencies sound good because he was also asking for the same for our releases, the next release.
Yeah. What is the version of Kubernetes? Do we know? Like we're going to support in 1.10?
Uh, I will check and get back to you. I'm not.
Yeah, I think this is the most important one from us because we don't have any dependencies on the training operator and on the KDP side for any other
I
component.
see. Got it. Oh, it's written here.
129, okay. 132 to 133, right? So 131 we're not going to support?
This thing you're not going to support 1.3.
Yeah. So okay. Yeah, because I remember previously we didn't jump for like 2 versions, right? From the latest release. Yeah, I can see that in the 1.8 we support 1.29, right? So I thought like we're just going to support 1.30 or 31.
Okay.
Yeah, I don't know. I think this is what we need, right? So we can
Okay.
construct a unit test, right? And integration test.
Okay. Got it. So you want to ask if it's possible to do it 1.30 instead of 1.30 or 1.31 instead of
Yeah, let me
1.32 and 1.
see. Let me see what we run today. Just a second. So we run this on 1.20, 29, 27, right? Yeah, but this is for training corporate. Yeah, from 27 to 29, right? Yeah, we might need to update it as well. Anyway, I think like getting the version will be helpful for us to understand, so we can change some of our CI/CD.
Okay. So you want to get a concrete number.
Yeah, that's right. That's right.
Okay. Good. Yeah. Yeah. I think that's it from my end from the
I
release
don't
feedback.
even understand why we're targeting 1.33 if it is not released yet, right?
Yeah.
It's 1.31, the latest version of Kubernetes, right? So
Yeah. I'll ask. I'll check on this.
yep, that's good. All right, anything else you want to talk about the release?
Nothing else. I'll put it on the group if there's any other on the Slack channel if there's anything else we need to discuss.
Yeah, sure, sounds good. Yeah, so for the release, like again, I just want to remind everyone that since we're working on V2 right now, we have plans to migrate, all of the existing users to the V2. I understand it will take time because we kind of like replacing the CRD definition completely. So I think the goal is to, again, support V1 for quite some time, like 1 year and a half, maybe 2 years, and then eventually, ask everyone to use the V2 version. And we will, like, for everyone who's just using Kubeflow installation, we will install the V1 and V2 together. But in the maybe next version of Kubeflow 1.11, we will remove the V1 version. But we haven't discussed yet what we will do with 1.11. But I think like I just want to ask, like, if you're using V1 in production, let us know, like, and please be like, please let us know like how hard it will be to migrate to V2 version your workloads on the training side. Yeah, but 1.9 we're still going to support it for quite some time. We're going to do some bug fixes and patch releases on the release branch. So I don't expect any issues there. Yeah. So anyway, so
I have
let's
one question.
yeah, go ahead, Pankaj.
Yeah, so basically, like if somebody is trying to integrate fine tuning as a feature in the product, so would you recommend going with the V2 version or like using the old version?
Yeah, I think so, right? It will be more scalable. It will be, you know, it has much more features, right? We should be because we just build on top of job sets, right? So especially with all this runtime integration. So if you kind of building the product right now on top of training operator, I would definitely suggest to do V2, right? And I don't expect any instability there compared to V1 version.
But regarding its stability, so like will it like we need to do a lot of testing, right? So
yeah, but I think it depends like what kind of product we're talking about. Are we talking about like a fine tuning using PyTorch and you know, or we're talking about something else like
fine
right?
tuning PyTorch.
Yeah, so I think so again, I think that you know if you're building something new, you should build it on top of V2, right? And because again, the main difference is orchestration is delegated to the Kubernetes batch, right? Not to us, right? So before we kind of orchestrating all the spots inside our controller. So right now the orchestration is up to the, you know, like kube controller manager, right? And job side is creating the jobs and jobs actually creating the pods, right? So I suspect you will have it like, you know, it will be it will be like, you know, scalable, and all the features which you have in the jobs, it will be supported with in the V2 APIs, right? Which we don't support it in V1. For example, pod failure policies, right? So we have restart policies, but we don't have like all this, you know, batch features within V1, right?
Yeah, will make sense. Yeah.
Yes. So I would suggest so it might be some issues with Elastic. So I think it depends on what you want. For example, like elasticity. I know that V1 will support Elastic PyTorch. So Elastic PyTorch right now it's not supported in V2. But like I mean, I think if we see that users actually want it, we can have some intermediate, like you know, short, like a medium-term implementation within our controller. Because the problem is job set doesn't support elasticity right now. I know there is some open discussions, but this has not been implemented yet, right? Yeah.
I don't see my hand raised because the Zoom interface changed, but we're interested in that as well. That we're working on an ensembles in HPC, and we would really like to be able to change job set, but everything is immutable. So there's a use case coming from our side as well.
Yeah, it makes a lot of sense. I think like a lot of use cases kind of correlates between each of us, right? Like each other. So like similar to, you know, job like startup policies, you know, elastic job sets, probably the stateful job sets. I don't know how it is important for HPC, like when I orchestrate like the volume during the orchestration of jobs. But I suspect there will be more features that we need to work together to implement on a batch job site and on a job set side, right?
Yeah, the design is interesting to think about because I was thinking about this morning. When you think about, I guess, job or job set, the way that it's not that it's not allowed to change. You can have different policies where something is like recreated or restarted. It's just that you have to make the decision about those rules a priori. And then you create it, and then your rules are, you know, they're going to become active and you can't make a change after that. What that doesn't allow for is uncertainty in what you want to do in different cases. And maybe that's not a strong use case if you're just like submitting your ML thing and you want to have some number of successful completions, then it goes away. But I think in a lot of more complex workloads where there's more nuanced simulation that requires like an if and else sort of deal. Like in this case, I need to do this thing, but in this other case, I need to do this thing. There needs to be a little bit more controlled and like you don't know right off the bat, right? And so that's sort of the use, that's the generic use case for wanting something that is changeable.
Yeah, it's kind of funny because I mean Aldo and other folks from Batch working group, they actually went. So I know that Kubernetes support Elastic index jobs, and they kind of gathering requirements from us.
Yeah,
you know,
that's how the Flux operator works.
yeah, a couple of years ago, and for ML workloads, there is still a lot of value, right? Because some workloads support elasticity, like Torch, for example, like you can basically allows you to dynamically scale up and down your training nodes, right? And especially on a large scale, you have to have this feature, right, available for you. Yeah, but I don't suspect a lot of kind of problems for us to integrate this within the job set, but that would be possible, I think. Yeah, so anyway, let me maybe share my screen so I can share the updates and maybe we can discuss this roadmap around HPC. Just a second.
Yeah, to kind of close up that point,
Mhm.
I'm going to be doing a presentation at some point, probably to the batch working group about the HPC use case, which is specific to ensembles. I can share with this group when that's going to be closer. I haven't actually made the talk yet.
When we're talking about ensembles, like, is it like, a combination of multiple jobs which work together within the group? Like, is it? Mhm.
So ensembles can be, so in terms of size, they can range from kind of, 20 to thousands of members. It's generally when you have something where it could be the same kind of entity, so like some number of nodes being run many different times, but you might also have different applications. But sort of the simplest idea of an ensemble, for example, would be like, okay, I'm going to run lamps at size 8. And I'm going to keep going until my simulation reaches some level of accuracy, and then I'm going to go on to the next step. That's the simplest, but they get much more complex than that. And I'll go, yeah, there's much more about it. I'll go into more detail in my talk.
Yeah, that makes sense. Because like I was researching some kind of complex topic about, I think it's called ensembling learning, when basically you kind of can train your multiple models together within the separate workloads, and then kind of like constructing the ensemble across multiple neural networks.
Yes,
It's kind of like,
that's a good
yeah,
example of a more complex use case. They're
yeah,
pretty
yeah,
cool.
yeah, exactly. And basically, you're kind of constructing the ensemble of multiple models together, and then you kind of like I don't know. I don't really hear about these use cases in production yet, like how people actually do this, for example, like fine tuning or training across multiple models together. But I think this might be a future kind of thinking, given that what we see on the LangChain graph part, like how folks today serve models, they try to get output from the one model and bypass it to another, right? So similar to this, maybe on the training side, it will be similar use cases around multiple neural networks stitching together, right?
I also suspect that will come up if it hasn't already.
Yeah, definitely. Yeah, it's interesting. So I think we've done really great progress, and thanks everyone who actually volunteered. I think we're on track. Um, the great thing that we kind of like merged the PR around this pipeline framework, which gives us a lot of, abstractions and extensibility in terms of supporting more plugins. Just a reminder, like if you want to see like what is this pipeline framework for, I can share the slides here that you prepared. I think this will be also helpful for you to understand like around like the extensibility for HPC, because I think our idea was to, I think previously you asked us about, can we use training operator not for ML workloads using MPI? I think our goal in the future to support not only train job and training runtime, but support more runtimes and more custom resource definitions. Because today, like we have these two CRDs, which can play together for different type of persona, like for platform engineers and for data scientists. But I understand that since we have MPI, like maybe HPC users, they want to have a different spec, right? So the goal of this framework actually, I'm not going to all the slides, but basically allows us to register custom runtimes, which might not build on top of job set, which might build on top of Slurm or Flux or any other customer source definition, and also allows us to leverage the custom plugins within these runtimes. So today, like we kind of like support MPI plugin and Torch plugin, which basically do some orchestration for PyTorch tasks and for MPI tasks. But also maybe you have your custom plugin where you want to use it within your runtime. So this also could be supported within this. And even more, we can also support not only train job, but other resources like maybe HPC job or whatever we can call it, right? And this spec would be specific to HPC user, right? So I think this allows us to have more flexibility in the future if, HPC users will see a value of MPI, but they don't want to use train job to trigger those MPI jobs, right? So So this I would like to, I think like our goal is to have a conversation during KubeCon if we have some, some HPC users there, and I know Yuki will be there to discuss what, from API perspective, what exactly you want to have. And do I have a similar vision in mind that you have a runtime, like maybe a blueprint or template, and I have a job which can kick off this, this template with a very minimal set of configurations. So from you, let me just ask you a question. So from your past experience, do you see like these differences between blueprint and actual training job, or not training, like actual job, when you want to start the HPC task?
So when you say blueprint, you're talking generically about a pattern, or is there a specific CRD abstraction that I should know about?
Yeah, like a pattern. For example, like I want to run simulation for XYZ, right? I kind of prepare it, right? And this take I kind of like stay stateful for like some time, like maybe a couple of months, and I'm just having my simple jobs which actually can trigger those, those templates.
Yeah, so a lot of HPC jobs that use MPI actually have this launcher worker design because you have an MPI launcher and then workers. And really the main difference is just like having MPI and then having the launcher and having the communication mechanism that works between the different nodes, which are different actual nodes. And I think really a big point is almost less about the design and more about branding. Because if I'm an HPC person and I have like a simulation that uses MPI, and I come and I see Kubeflow training machine learning, my brain is not going to trigger that this is something that I could use because, it's maybe my simulation is, for physics or chemistry or something like that. So I think there are probably other blueprints that we could describe for HPC, but the big bread and butter of HPC land tends to be MPI with that sort of design. And then the other kind of interesting nuance that we do, or at least that we're doing with Flux, is just the idea that like you have a top level scheduler or workload manager that might run, run a top instance of jobs, but you can actually launch sub instances within that. So you almost have your jobs launching smaller trees of jobs. And that's something also that I'd like to see in, well, given that Flux is in Kubernetes, we do have that in Kubernetes, but I'd like to see it expand to more of these workflows as opposed to being kind of a flat hierarchy.
Yeah, that makes sense. I think the goal is we can create those runtimes, right? Which will be specific to HPC. Because training runtime reference, right? So training runtime today has some policies, like I think we have pod group policy and ML policy and template, like three these entities, right? I guess for HPC we probably need to have different entities, right?
You'll need the pod group for sure. MPI does not do well, not as a group.
Yeah, that makes sense. So we probably need gang scheduling, right? But maybe you need some another policies which will be specific to HPC, right? So we don't know all those things. I just want to say I think it is possible to achieve with this architecture, in terms of extensibility and how we can extend this framework, runtime framework. And maybe because I remember like previously we've been discussing that we need to have a place for HPC users to run those tasks simulations quickly on top of Kubernetes, right? So we need to see how we can, work together to provide those blueprints for HPC users, right? Because again, so from the ML perspective, right, we are planning to give users, blueprints for like fine tuning, blueprints for just, basic ML training using those frameworks, right? But what about blueprints for HPC, right?
Yeah, so I actually started this yesterday. I would have started it earlier, but I had another thing I was working on with Containerd. And what I'm basically doing to start, because obviously the work here isn't, done or close to being done. But what I'm doing is I'm just starting with job set, and I'm taking a bunch of HPC workloads. So basically containerized stuff that doesn't have, Flux hard coded in it. It might just have like lamps or AMG or Stream, or we have a ton of applications because we just did a big performance study, and I'm implementing them in job set. I'm also just doing a vanilla Flux cluster in job set. And so yesterday I made just a quick library that uses like Mamba or mini Mamba, I think it's called, just because I think for a lot of machine learning stuff in these containers, like Python is present. Like it's hard to find an ML oriented container these days that doesn't have Python. I mean, I'm sure it's out there, but like I haven't seen many. So basically with this tool, it easily installs Flux Core and Flux Sched, which gives you everything you need for communication between the nodes, sharing files. And so basically it's like one command to install, and then the next line you run your workload. And so I want to do that for a bunch of different workloads. Then we'll have this big set that, already could be useful for the HPC community. But then we can look at that and then figure out how it fits in this framework here. How can we make this more of like a template that, what further, I forget what you called them, blueprints, policies, what other policies do we need to better enable this? One big thing with HPC, and this isn't true for all workloads. So for example, LAMPS is very CPU bound, which is something that I learned by using it on Google Cloud, and Google Cloud did very well. But a lot of HPC workloads need a lot better network than is traditionally provided for most clouds, aside from Azure InfiniBand or whatever. And so I don't know if anyone has thought about policies that have more to do with network, or making sure that you select the right devices if they're available. So like the elastic fabric.
Like affinities, right? And tolerations. I think I know that you can point me if I'm wrong, but I think batch community, they've done some work in this field, right? In terms of association with specific node group, right? To make sure we have appropriate device placement, right?
Exactly. The basic goal is to make sure that if I'm a scientific HPC user and I come along to Kubernetes and I want to quickly deploy an application, I shouldn't have to think. There's a lot of nuances, especially between cloud, about what my blueprint or my template should look like. And the goal would be that they don't have to think too hard about it, that someone else has done the thinking and we give them a template and they can kind of run off and at least get started and then tweak it as they need.
Yeah, as far as I know, this kind of queue responsibility from the batch perspective, because queue will dispatch the workload on appropriate with appropriate selectors. Yeah, but I agree in terms of like the blueprints give us flexibility to set up those affinity rules. Maybe select the queue, right? Because I guess maybe I'm wrong, but I thought the queue is actually have a different queues, basically a queue with K, right? Like this project around the job dispatching, and it actually allows us to select the appropriate queue and make sure the workload has the good network connection between the different instances, right? Yeah, but
I think what you're saying is there's going to be other layers involved. And I agree. I completely agree.
Makes sense. Yeah, so any questions so far? So just an update, right? So we merged this pipeline framework. Right now we're working on I think different plugins, which is Torch, JobSet, and also the plugin around, let me open this. So JobSet, PlainML, and Torch plugin. So PlainML basically is the plugin which just use Python entry point and using just number of nodes and spot group policy without any additional features like PyTorch Elastic. Torch plugin using some Torch run capabilities, like it's setting the appropriate environment for Torch run. It also setting some configuration for PyTorch Elastic in the future once we support Elastic training. And the JobSet plugin actually built the JobSet based on those policies and based on the train job configuration. So once we have this, we can easily create the simple runtimes. I think I already have some of the working examples in this PR. So one of these runtime actually already working. So the idea is we have this cluster training runtime, and basically we have this ML policy, which define number of nodes, number of processes per node, and a job set template where we have a single trainer node with one of my example images. And this is working. And how to kick off the job, you just basically create a train job and you reference to this training runtime. And you can override the number of nodes, number of processes per node, and pass some environment variables. So this is working. I think we also need to do some work in terms of support other APIs and support other plugins like MPI. This is in progress. I think we also have done some progress on the validation side, which we also need to take a look and review. We have some self-validation and webhook validation, and we need to merge. Yeah, and I think we also have a initial SDK implementation and open MPI spec generation. Any questions on the V2 progress from the community? Maybe you want to talk about?
Now, you mentioned MPI. What's sort of the
Mhm.
general direction? I know there's a lot of talk about like that
Yep.
the MPI operator is going to be encompassed here. It's going to go away, and I'm wondering where the discussion is now about that.
Yeah, I think initially we want to support MPI v2 in MPI plugin. So MPI plugin is nothing just to construct the appropriate job set. And I guess so you can like from your perspective, the orchestration of host files will be still part of MPI plugin implementation.
Yes, that's true. Yeah.
Mhm. Okay. I think so I think plugin has this API called how you call it, like for orchestration.
So what do you mean?
Like basically, I know we have a builder, right? In the plugin, in the runtime, in these plugins, right? Um, I'm wondering, do you have any interface to do the orchestration, right, for the plugins?
Yeah, we will MPI host file creation implement in the inside of plugin. So actually so each plugin implement each plugin interface. So in that case, so for MPI MPI plugin is plugin, not interface. So so this concept can be seen in my Kubeflow pipeline framework, right? Yeah.
Yep.
Yes, this one, yeah. So this is so similar concept as Cube scheduler scheduling framework, but it is a little bit different from this.
Yeah, that makes sense. So basically, we're gonna have a custom function, custom APIs for each plugin, right? Where we can do whatever we want to do, right?
Yeah.
Yeah, that makes sense. Makes sense. Yeah, so I think we need to just bypass this orchestration to the plugin, API plugin, and then we basically, when we do the reconciliation, we just need to invoke this this API to do the appropriate, creation of host files and the config map, right? Attachment. Yeah, I think this is what we do. I think the question around, do we want to keep MPI operator as a project, right? I think for now, yes, we do. And we need to understand what is the direction there. Because back to my point around this kind of architecture is flexible enough for HPC users, but we need to design the API which will be specific for HPC, right? Like not train job, right? Not using train job to trigger those, API tasks, right? But something else, right? Maybe we can call it HPC job or something more specific to this, use cases. But we don't know yet because we don't know the API, right? Like what are the parameters that you as a HPC user want to have, right? And want to change frequently, right? Yeah.
Yeah, actually, so here is only one of MPI operator approver here, me. So we need to discuss how we can go with train job and MPI operator in the future with other MPI operator approver, Yuan and other yeah, so or approvers, yeah.
Yeah, I think the general question that again, like that as before, the separation between personas, is it still exist in HPC world? Like if we take a look in this slide, right? When I have a platform engineer and a data scientist, right? Do we have this still separation in HPC world? Or they usually kind of the same set of people?
Yeah, so that depends on the so company. So actually, so for deep speed or some else so machine learning training specific workloads using MPI as backend network. So in that case, so we can follow the similar persona separation as we can see here. But so in the case of actual supercomputer, this situation that does not match with supercomputer use cases. So actually for MPI workloads, so two situations. Yeah. So we
Yeah,
need
I
to
understand.
support, yeah. So those
I
situations.
think, yeah. I think my question was more about just about HPC. We're talking about simulations, right? Those simulations can be triggered using different HPC technologies, right? So I think my question is, can we still separate the template or blueprint or a recipe, whatever we can call it, from the actual job we want to trigger, right? Like, is there any set of parameters you want to maybe configure on every startup of the job, like maybe your source code, right, that you want to run, or something else, like maybe environment, right? So can we do this separation, right, from those simulations, right?
I
Yeah,
see. So you mean so for simulation use cases, so we
yeah.
support in NP operator. But so for machine learning training situations, but still it is used by NP connectivity. That use cases should be supported in train job, right?
No, I think I'm saying like I'm just in general asking, right? I don't know like where we're going to support it, right? But again, I'm not talking about again if we just not talk about ML at all, just about HPC, right? So in HPC world, can we separate the actual job from the template? This is my question, right? And where we're going to support, we can discuss it, right? Maybe we can create another project. Maybe we can, update and, improve MPI operator. It's more about like architecture, pattern, but separation, right?
You mean, can you
Um,
run the job without the template? Is
Yeah.
separate? Is that
Can
what you
you
mean?
can you run the job from the predefined template, right? You kind of pre-create template and have a job with minimal amount of configuration, right?
I guess I don't understand the question.
So
I thought the original
yeah.
question was about roles, like, can you kind of abstract that a data scientist that's running a machine learning thing is similar to a data scientist or a physicist that's running something in HPC that has a similar pattern?
Yeah.
And I'd say yes. But you're asking about separating the job from the template, and what does that mean?
No, I think so. Basically, yes, I'm asking the question you the like the part that you said before. So like similar to researchers and data scientists, they kind of different set of people compared to people who are actually building those templates. Because the main goal of train job is to provide minimal set of configuration data scientists need, right? They only needs
Oh, I
information.
see.
Yeah.
I would say generally with HPC, a lot of jobs tend to be snowflakes in the sense that you absolutely would start with them totally separate from
Okay.
Kubernetes or the template. And it's very unlikely that, even just lamps, there's like 1,000, like lamps is actually like more like thousands of different, simulations within that software suite. So you usually start with something, you have a lot of customization, and then you tweak the heck out of it because you want to optimize it on your resources, whatever they happen to be. And then you put it in the final environment to run. So
Mhm.
you probably would start with a template in this, like, to understand how to eventually put your thing into it. But it's unlikely that the template would match exactly what you want.
Yeah, I see. So these things we need to understand, right? Because from again, why we did this, right? Because data scientists don't know about Kubernetes anything, right? They just know that I want to pass these parameters. I want to use, for example, even for Python, like we have this Python SDK, right? I have this Python function. I want to scale it across multiple PyTorch workloads, right? They don't need to provide anything else, right? Anything else is hidden on the template side, right? All this node affinity, gang scheduler patterns, and other things which is not specific to data scientists, right? So I just want to find similar patterns on the HPC side, right?
Yeah, so I'm working on right now a job set that is
Yeah.
running Flux and lamps. And if I were like an HPC person coming along and I would want to customize this, really the things that I care about are like, how big of a scale is my job going to get? So
Mhm.
at least staring at this particular job, that would be completions and parallelism. And then under the command, there's one line that I have that makes sure that Flux is installed. And that's pretty simple. But then the main thing that I care about is the command to launch my job. That's where I put most of, the parameters for my simulation. I could technically defined environment variables just in that, command bash xc and then pipe and then the big section there. The other stuff, so like, for example, Flux needs a curve certificate for kind of signing things. That could be part of a policy. That would be packaged in whatever is the Flux HPC thing, and the person wouldn't have to think about, because without it, Flux wouldn't work as it's proper. But and maybe an expert user would be like, oh, I'm going to instead put my environment variables in the actual, environment section for them as opposed to the bash script. But, staring at the entire job site of the job, like the entire thing is very big, but the sections that I'd actually need to edit are very small. Like I could, I'm kind of staring at these, and I could very easily just take like Jinja 2 and have these generate very easily by asking the person to give like the size and the command. And then I would
exactly.
generate the
This is what, exactly. Well, this is what we did for train job, right? We just provide a set minimal of APIs that user can configure, right? And anything else is hidden on the template side, right?
Yeah. Nobody wants to see this much YAML. No, I'm just kidding.
Exactly.
It's fine. Even when I started working on this morning, I was like, oh my God, there's just like so much. Like, what is this doing? Oh yeah, it's really not doing that much. Like,
it will be like selectors, right? And the other policies and other, configurations, you don't need to have on every job submission, right?
Yeah, I think the one extra bit, so what I'm doing right now is I'm for the curve certificate, that uses a library that so for the Flux operator, that has it built into the Go code. It's like a library in C or something, so that gets generated by the operator. For the simpler use case I'm working on now, I basically just run the container. I run a container with Flux to generate it, and then I use, kubectl to generate a config map, and then the config map is mounted. So that would be if for example, Flux was one of the, what do you call it here? A plugin?
Yeah, we call it like, we have policy and we have like that runtime, right? So runtime is like, consists of multiple policies and a template.
Okay, so Flux would be like a runtime.
Yep.
Okay, so yeah, if Flux was the runtime, we would have one of the components in that really cool scheduler framework like setup be something to generate that key. Because you can use like a pre-generated key, but then, everyone knows about it. You usually want to generate it on the fly. That's for ZeroMQ, which is a communication alternative to SSH, which is better, but I won't get into that.
That makes sense. Makes sense. So that does make sense to you what I'm talking about in general, like.
Yeah, your question about like, is there some smaller set of things that you can abstract away for the HPC community? And I think yes, I think a lot of the HPC workloads that we run would fit well into this kind of design.
Makes sense. You could have any, go ahead.
Yeah, so that makes sense. So anyway, so we need to consider so how we should go MP operator, because MP operator and the train job has deprecated responsibility across Kubeflow community. So I'm not sure. I'm not exactly sure what is solution. So
we just need to design an API, right? Design an API for job and design an API for runtime, right? And just understand like how those things can play together, right? If we can do it, we can just have two controllers, so one controller who can orchestrate those things, right? Because the runtime framework is already flexible enough to support ML and HPC use cases, right? As patterns that I was talking about, right? You don't even need to use this ML plugins at all, right? You can just use API plugin or like Flux plugin, whatever plugin you want to integrate, right? And then you can bypass the Flux as the template for your runtime job. I think we call it inside the framework the runtime job template, which can be literally any Kubernetes object, not job set even, right? But anyway, let's think about it later, because maybe we can come back to the API once we have some initial API implementation for ML, and then think about how we can process, right?
I agree. So I will be in KubeCon and SaltXT. So if HPC users have any feedback or concern, so can you contact me via Slack? So we can meet face to face in the conference. Yeah.
I won't be at KubeCon. I don't know if there is going to be some in-person meeting. Do they have meeting rooms where people can virtually join, or is that like an impossible thing?
We've done this on the on the backside of the conference room. So
Okay, I'll
good.
take that as a no.
Yeah, I mean, it's hard to do there because there are so many people in the KubeCon, but maybe you can find some place there. We're gonna give a talk there, so maybe sometime we can find the space, because if Yuki will be there, I will also try to be there, but I'm not sure yet. But at least Yuki, if you can have some conversation, will be really helpful for us to understand the direction. Yep.
Yeah, and once the initial sort of ML
Mhm.
runtime backend plugins are implemented, I'd be interested to work on either Flux or even give a shot at the MPI operator.
Yeah, sure. Sounds great. All right, so I think like the P1 kind of priorities for now is right now it's finished this PR for supporting the Jobset plugin and Torch plugin, because we want to really have it before our demo to showcase it during the KubeCon. I think we also need to finish this review PR for validation and other things around server-side apply, right, and the self-validations. Any other questions? What?
I don't know if it's the right platform for us, but like in the PR, like I have one question for.
Yeah.
Like, can you open that 2170?
Yeah, 2.1. So which PR?
So basically this one, implement job set plain ML and Torch plugins.
Yeah, this one, right?
Yeah, no, this one.
Did you?
Implement job set plain ML and Torch plugins, which you just opened a while. One
Yeah,
that I share. It's 2308.
2308. By the way, you can share one of the scap around topology or scheduling, which is helpful for node affinity. That I wanted to talk about before. I think this.
Yeah, this is comment against for network topology assigning use case. Yeah.
Yeah, 238, right?
Yeah, 2308. Yeah. So here, like in the ML policy, the number of nodes are 5, whereas in the trainer, the number of nodes are 2. So like, what's the significance of these two different number of nodes?
Yeah, so the main motivation to put number of nodes under ML policy to allow user to kick off this runtime without any trainer configuration. This is specifically for LLM runtimes, right? So maybe we know how many nodes we need to do fine tuning. Maybe we know how many GPUs you need. We just configure this on the runtime. You cannot override. You can override, but it's not necessary. If you want to provide more resources, you can always bypass the number of nodes within train job, right? So there are a set of configurations you can override from the train job on the job set side, on the runtime side. Does make sense?
So like ML policy will override this whatever we are passing to trainer.
No, it's different. Trainer will override whatever you're passing on ML policy, because ML policy is stateful. Like, this is a stateful component, right, which is sitting on the cluster without any changes. If you want to kick off the job, you just need to create this train job where you can pass the number of nodes if you want to, but it's not necessary, right?
Okay, got it.
Yeah, it's kind of override. Yeah.
One more doubt in this same thing. Can we override the command or add arguments now from
Yes.
the thing?
Yeah. Command can be overridden already. So I have this parameter called so in the trainer, right, API, we already can override command and args. Trainer API, right? So you can override image, command, args, environment, number of nodes, resources per node, and number of proc per node.
Got it. Yeah, makes sense. Thank you.
Yeah, so we also give enough flexibility around even pod spec override. So this is specifically for if you want to override some other low-level parameters, you can also do so on the train job. I think this was done as part of our design thinking around how we can give enough flexibility on the train job side. Yeah, but this is not yet implemented. All right, any other questions on the progress? I think we wanna, I think the one is the point, I think we wanna discuss how we gonna have this LLM trainer, and we haven't got a chance to discuss it within the community. So the goal is to have a custom dataset initializer, custom model initializer, and also custom trainer to simplify the fine tuning. So today in the V1, right? So I know Dipankar has worked on this, but basically we have a custom trainer which can fine tune some LLMs. It's living here. I think we need to understand like what we should do with the V2. And we want to start with some llama-based trainer and to see if we can abstract it to support not any LLM, but maybe a set of LLM that we can support as the community, right? So maybe we will say we support Llama 3.2, maybe Gamma, the latest version, and Mistral, or some of the models that everyone is using, and maybe add more recipes in the future. So I know TorchTune. So PyTorch has a framework called TorchTune. So and they have a lot of interesting configurations we can take a look, and just to see what kind of models we want to support as a community moving forward, right? And how we can design our trainer to make it flexible enough, right? Yeah, so I don't want to maybe discuss this right now, but if you have any ideas or suggestions, let me know. I know we work with Salish to see how we can at least have fine-tuning for Llama initially, and can we adopt the script to supporting other models, right? Yeah, but I don't know yet. I know that our script is using the Hugging Face transformers, which I don't know if it's as ideal, or we should use the PyTorch native APIs, right? Yeah, because there are some things we need to talk about around FSDP. Can we use this with Torch Run? Should we have an accelerate, or we should have an accelerate as an entry point, right? So these things I don't know about right yet.
One question I want to kind of throw out and leave that I'm curious about is with the new announcement of what constitutes open source AI, does that change any of the work that we do in this space?
By open source AI, what exactly do you mean?
So the open source initiative announced after they've been working on it like a couple of years, I think. I think they announced on Monday their definition for basically what constitutes open source AI models. And a lot of the models you just named don't fit the bill for various reasons. And I haven't, read a lot about it beyond that announcement, and I've read kind of the rules, but I'm wondering if there are any trickle down implications for communities that are using the models in open source projects.
Yeah, I think it's a good question, actually. I know that Llama has some set of, requirements. You need to basically, you need to follow the guidelines and the licenses there. And also there are some models that around might have a different licenses. I haven't explored their definition deeply, but I would love to, hear the feedback from the community, what we as open source project want to support, right?
Yeah, me too. I'm topic for this week.
Yeah. I think it's interesting. Do you see any issues from us to providing just an instructions on those models which could be not fully open source?
So I'm the wrong person to ask. I personally don't, but I don't know a lot about it. So I wanted to insert that thought into everyone's head so people can start thinking about it and looking into it.
Yeah, that makes sense. Yeah, I would love. I think after building infrastructure, we should deeply think about what we should support and what is the policies around models right there. Yeah, but I think since again this is just an infrastructure component, right? So we're not building something on top of this open source models.
Yeah, exactly. Yeah,
it's not about application, but yeah, I think it's a good question. Yeah, so I think we're almost over time. So just a reminder, again, we're gonna give a talk about this V2 APIs in the KubeCon. This is our, I think it's on November 16th. 14th actually, November 14th on Thursday.
Oh, exciting.
Yeah. And I think also we have a Kubeflow summit in London. Actually, we kind of have a place for us to talk about different things. So if you want to submit a talk, feel free to do so. I think the deadline is end of November. But I'm super excited to actually have a summit in the London here, to make more people
I'm
can
guessing
talk
that's in person.
Yeah, it's I think this will be in person in London. I wish you can all, come here and just we can talk about this in the summit, but it will be fun.
Yeah, let me
So-
just take a swim.
Yeah. Yeah, exactly. Yeah, so let me know if you have any questions for this. I think we're still working there on the proposals and on the planning there. But I think it should be really a lot of updates will coming from the Kubeflow ecosystem in general. Right. Any last questions or comments? Talk about?
There is a pending PR, I think, for Kubeflow. I think the UI. There is this one bug that with Cypress that I think it's an error with it's an error that's been there for quite some time. So I was just thinking what thoughts anybody has about any ideas about that, basically. If we can possibly use a different framework
Yeah.
in place of Cypress, because this is a recurring issue, this is a known issue, and it's currently, I think, blocking the CI pipeline for Ketib. I think
Yeah. So from your perspective, Tariq, like it will be hard for you to switch to different framework from Cypress?
No, I think it's just it's not going to be difficult, but it's just a question of just getting it implemented, basically. So I can take a look at implementing it with, let's say, a different framework and see what everybody has to say.
Yeah, let me ping Matthew and other folks from Notebooks Working Group about it, and if they agree, we can just move forward, right? I will also pick Ender in the Slack channel right now.
Yeah.
Right. Thank you for doing this, by the way. I think it's really helpful. It's final unblock our KTPI, which was broken since April, right? So we need to do something there, definitely.
Yep.
Right.
All right.
Thanks everyone then for your time. See you soon. I think in 2 weeks. I'm not sure we're gonna have a meeting in 2 weeks. Otherwise, we're gonna cancel it and gonna have it in 1 month. But feel free to reach out in Slack. I think we'll have a really great progress and looking forward to actually show this to the whole world very soon. Exciting to work with everyone. Thank you. So
Yeah.
see you soon.
Thank you, everyone. Bye.
Thanks, sir.
You.
Thank you.